Good morning. We are doing lesson 9.5 today. I'll get to that in 1 second. Just a preview of what we learned. In the past, we learned to multiply two factors, like x minus 3 and x plus 4, to figure out what goes inside, like x times x is x squared. And we could fill all of this out to get x squared, and then combine these. That would give us plus 1x minus 12. So this is our polynomial. Now we're going to have to work from this backwards to get these two terms. Alright? So it's hard to figure out what two terms are going to go here and here because we combined them to get this middle term. So that's where our diamond comes into place. This diamond is going to help us figure out what two answers, what two things go on either side here. Those are actually these two boxes right here. So we're going to use what we know about diamond problems to help us solve today. So here's our first polynomial, x squared plus 11x plus 18. And this is what we call this equation, ax squared plus bx plus c. We call this the first term, the middle term, and the last term. The a, b, and c are just numbers. So here a would be a 1, x squared is x squared, b is 11, and c is 18. So these letters and x's help us determine what goes where. So here, this term, ax squared, is right here, and c is right here. Since they're touching, all we have to do is multiply the first term and the last term. Well, 1 times 18 is 18. And there's an x squared there. So that goes on the top. And then bx is our middle term that goes on the bottom, 11x. So now we need to figure out what two numbers are going to add to get 11, but multiply to get 18. So if you think about it, the only things that multiply to get 18 are 1 and 18, 2 and 9, and 6 and 3, or 3 and 6. The only ones that add up to 11 are 2 and 9. So in order to get these to multiply, we would need a 2x and a 9x. Those would multiply to give you 18, and x times x is x squared. And then they would add to give you 11. 2x plus 9x is 11x. So here, this next box tells us where to put these on the inside, because we're working our way out to figure out what goes on the top and what goes on the sides. So the only things I need for my diamond are these two side pieces, and they go on our diagonal. Those were the two that we combined together to get to this middle 11. It doesn't matter which one you put where. It tells you to put the first one up here and the second one down here. It doesn't matter, because you just ended up multiplying or adding them together anyways. Now, what goes in this first box? Well, ax squared, which is our first term, which is 1x squared. And in our last box, we have to put c, which is right here, 18. So these two don't actually go anywhere in our box. They just helped us to figure out the two side terms. So now we're almost done. We need to think what goes on the top and what goes on the side of our box. So what multiplies to give us x squared? Well, 1 times 1 is 1, and x times x would give us x squared in that box. If we move over to the next one, if we need a 2x, 1 times 2 is 2, and there's already an x there, so the first one is 1x plus 2. Then if we go down here, we need 9x, we have a 1, 1 times 9 is 9, and there's an x. And you got to check the last box. Does 9 times 2 gives 18? Yes, it does. So our answer is going to be 1x plus 2 times 1x plus 9. This is a positive 9. This is what we are looking for. These are what are called two factors that would multiply to give us this whole polynomial that we started with up here. Alright, let's try another one. Here's our first term, middle term, last term. To get what goes on the top of our diamond, we multiply the first and the last terms, ax squared and c. So 2x squared times 2 is just 2x squared, because this was a 1. 1 times 2 is 2. In the middle, 3x, that goes on the bottom. We need to figure out what two terms multiply to get 2, but add to get 3. Well, the only things that multiply to get 2 are 2 and 1. So they each need an x to give us x squared. 1x plus 2x, yep, is 3x. So these two side terms are what are going to go in our diagonal here, the ones that we would have combined together before. So 1x and 2x. Again, doesn't matter which one goes where. Our first box is our first term, x squared. Our last box is our last term, 2. And then we need to factor, meaning what multiplies, what can we pull out of this? Well, an x times an x would give us x squared. X times 1 would give you 1x here, would be a positive 1. To get this box down here, we would need x times 2. And you just got to check your last box. 2 times 1 is 2. You can double check every single box to make sure that what you put on the sides multiplies to make what's inside. So this is a positive. So my answer would be x plus 1 times x plus 2. That would give us this polynomial up here that we started with. Alright, let's just take this one at a time. First, multiply your first and your last term. 12 times t squared is just 12t squared. Our middle term is a negative 8t. Don't forget the negative. That'll make a big difference. And we need to figure out what two numbers multiply to get 12, but add to get negative 8. Well, multiples of 12, or factors of 12, 1 times 12, 2 times 6, or 3 times 4. The only ones that are going to add to give us 8, 3 and 4 gives us 7, 6 and 2 would give us 8. But they all need to be negatives, so 6x and 2x. Two negatives there add to make negative 8, but multiply to give you positive 8. So these two terms are what go in our diagonal. Negative 6x, negative 2x. And then our first box here is not this term. It's whatever was the beginning, our first term, t squared. Oopsies. I made a mistake. I started using x's. We have the letter t. Let's use the letter t like they want. I'm going to change these to t's as well. And our last term comes from the last, right here, 12, goes in the last box, plus 12. So think the only things that multiply to get t squared are t times t. And then t times negative 2 is negative 2t. And t times negative 6 is negative 6t. Double check your last box. Negative 6 times negative 2, yep, makes a negative 12. So our answer is t minus 2 times t minus 6. Alright, I would like for you to try this one. Place the terms in the correct area based on these letters, and then factor them out. I know a squared times 10 is 10a squared. My middle term is 7a. Well, the only things that multiply to get 10 are 1 and 10 and 2 and 5, so it must be 2a and 5a. That adds to give us 7 and multiplies to give us 10. So we have 2a, 5a. First term was a squared. Last term was 10. So we have a times a gives us a squared. A times 5 gives us 5a. A times 2 is 2a. And then double check, 2 times 5 is, yep, 10. So this one, our answer is a plus 5 and a plus 2. Alright, we're doing lots of these today just to get good practice. Multiply your first term and your last term to give you this top piece here. 21 times x squared is 21x squared. Our middle term, negative 10x, goes in the bottom. So the only things that multiply to give us 21 are 1 and 21 and 3 and 7. So the only thing that's going to add up to 10, well, 3 and 7, if they're both, negatives maybe? Because we need a negative 10x. A negative and a negative, that'll add to give us a negative 10. Will that multiply to give us 21x squared? Yes, it will. So we have a negative 3x and a negative 7x. My first term was x squared. From here, my last term is 21. And then figure out what multiplies to get x squared. Well, x times x. And then x times negative 7 gives me negative 7x. X times negative 3 gives me negative 3x. And check the last box, does it make sense? A negative times a negative makes a positive. So our answer, our two factors in our parentheses are x minus 7 and x minus 3. Alright. Ooh, one last thing here. This one, if you noticed, was equal to 0. Oops. So if this is equal to 0, we have to solve both. This was from our previous lesson. If this times this equals 0, well, either this equals 0 or this equals 0. So x minus 7 equals 0 or x minus 3 equals 0. We have to solve both. So if you add 7, x equals 7, or x equals 3. Now this part here, you might be able to do that in your head and that's just fine. But I need two answers. Because this is where we would cross the x-axis if we were to graph it. Alright, next, multiply your first and your last term to get the top. Negative 30 times n squared is negative 30n squared. A negative 7n goes in the middle. Multiples of 30. We have 1 and 30. That's not going to work. 2 and 15. Well, that's not going to give us 7. 3 and 10. Will that give us 7? We also have 5 and 6. But I think 3 and 10 might work. 3n and 10n. But one of them needs to be negative in order to make a negative 30. We need more negatives overall, so maybe the negative 10. 3 minus 10, yep, is negative 7. So these are the two terms I'm going to put in my diagonal. 3n and negative 10n. My first term was n squared. My last term was negative 30 from here. So if we factor this out, n times n is n squared. N times negative 10 will give me negative 10n. And same thing here. N times 3 is 3n. Check the last box. Does it make sense? If it does, we can write out our factors. N minus 10 and n plus 3. It's a positive. All equal to 0. Don't forget, this is equal to 0. So we need to solve both. N minus 10 equals 0 or n plus 3 equals 0. So if I add 10, oops, I don't know why I'm adding 10 over here. Too much. N equals 10. Same thing here, subtract 3. N equals a negative 3. Feel free to slow down, pause the video again if you need. Alright, this next one's the same, except I'm giving a little bit less structure. You got to figure out what goes where. And This doesn't look like a nice polynomial. It's not equal to 0 and it's not multiplied. So first, I'm going to multiply this or distribute my parentheses. Don't forget this is a negative 10 times both of these. This x squared is just out front. Negative 10 times x is negative 10x. A negative 10 times negative 1 makes a positive 10. But we need it equal to 0, so I'm going to add 11 over to the other side. And we get x squared minus 10x plus now 21 equal to 0. So I'm going to multiply my first and my last term to get what goes in the top. So x squared times 21 is 21x squared. The bottom is our middle term, negative 10x. And we just did one similar to this. Multiples of 21 are 21 and 1 and 3 and 7. So it must be 3 and 7. 3x, 7x. But we need to add to get a negative, so they both must be negatives. Two negatives will multiply to make a positive. So next, we need to draw our own box here. Oh, that's a circle. So draw yourself a rectangle or a box here. And these two terms that we just figured out, remember they go in our diagonal here, negative 3x and negative 7x. And then our first term comes from our equation right here is x squared. Last term is 21. And then factor out x times x is x squared. X times negative 3 is negative 3x. X times negative 7 is negative 7x. And check your last box. So we have x minus 3 and x minus 7. This one was equal to 0, so we need to solve both. So if I solve these, add 3. Well, 0 plus 3 is just 3. And add 7. X is 7. That's it. We did that one a little bit more complex, but same steps. Here's another one very similar to it. We got to distribute first. If you want to draw a box to multiply that first, you may. I'm going to do it without it this time. W times W is not 2W, it's W to the power of 2. There's 2 W's there. W times 8 is 8W. And we need it equal to 0, so I'm going to just add 15 over to the other side. So it's equal to 0. We have W squared plus 8W plus 15. You can't combine these together because the 15 does not have a W with it. So here are our three terms. Again, multiply the first and the last to get to the top number. The middle goes on the bottom. Now multiples of 15. 1 and 15, 3 and 5, and that's it. So it must be 3W and 5W, which multiply to get 15 and add to get 8. So then I'm going to draw my box. And I'm going to put my two terms on the sides from the diagonal here, 3W and 5W. Again, those two doesn't matter which one goes where. But our first box is our first term here, W squared. The last box is our last term, 15. So W times W is W squared. W multiplied by 3 gives me 3W. And W times 5 is 5W. So I have W plus 3 and W plus 5 all equal to 0. And we need to solve both. W plus 3 equals 0 and W plus 5 equals 0. Some of you might know you're going to have to subtract these and you're going to know your answer right away, and that's fine. W equals a negative 3 and 0 minus 5 is negative 5. Again, you don't need to graph it, but this would cross at negative 3, which is here, and negative 5. So if we were to graph it, that's what that would look like. Something like that. All right, next one, same exact type thing. It just says find the zeros of the function. Again, meaning find out when it's equal to 0 what the two answers are. It's just a different way of saying find the two answers, find the solutions, find the zeros, find the roots. They all mean the same thing. So we're going to multiply our first and our last term. 32 times x squared is 32x squared. Our middle term is negative 18x. Now 32, what are the multiples of 32? Well, 1 and 32. If we divide by 2, 16 and 16 is 32. 32 is not divisible by 3, but I believe it is divisible by 4. 8 times 4 is 32. I think that's it. 6 is not going to work. So which two are going to add to give us 18? Well, what about 2x and 16x? Those ones might work. We need them to add to get a negative 18 though, so they must all be negative. That when you multiply will give us a positive. Good. So these two are going to go on the sides of our box, which we need to draw. So a negative 2x and a negative 16x. First term comes from the equation x squared. Last term from the equation 32. So I know x times x is x squared. X times negative 16 has to give me negative 16x. And x times negative 2. Check to make sure the last box works. And it does. So I have x minus 16 and x minus 2 all equal to 0. So solve both. Oops, x minus 2. So if I add 16, x equals 16. If I add 2 here, x equals 2. Those are my two answers. All right, last question. We're almost done. It says patio area. A community center is building a patio area along two sides of its pool. There's cement that you pour so you can sit on it when you're in your chair. It says the pool is rectangular with a width of 50 feet and a length of 100 feet. The patio area will have the same width on each side of the pool. So that's what x is. We don't know how wide it is, but we know it's the same. So they used x for both. Write a polynomial that represents the combined area of the pool and the patio. So if you think about this whole side right here, we have x and we have 100. Well, x and 100 we would write as x plus 100. They're just next to each other. This and this. This side is 50 plus x. Well, we're writing a polynomial to find the area of a big rectangle, because this whole thing is one big rectangle, is base times height. Well, we just figured out the base. The height is x plus 50. So we need to draw a box to multiply and write a polynomial. So we're going backwards. We're going back to lesson 9.4 for a minute. And we're going to draw our box so we can multiply this. We have x and 100, x plus 50, and we're going to multiply. X times x is x squared. X times 100 is 100x. X times 50 is 50x. 50 times 100 will give us 5,000. Not 500, because that would be 5 times 100. This is 5,000. So we have x squared, 100x and 50x, that's a total of 150x, and then plus 5,000. So they're telling us now, here we have this, Now the combined area, it should be equal to 8,400 square feet. Well, now find x. If we know x squared plus 150x plus 5,000, that whole area is 8,400 square feet. Now we need to find out what is x. Well, in order to solve this, we need it equal to 0. So I'm going to subtract 8,400. So this is the same. And we're subtracting. There's more negatives, so this is going to be a negative number. 84 minus 50 would give us, well, 80 minus 50 is 30. And there's a 4 there. 84 minus 50 would be 3,400. So now, where would we go from here? Well, we know how to use a diamond. Multiply your first term and your last term. This is negative 3,400 x squared. On the bottom we have 150x. This is a tough one. I'm going to use my calculator for this. So I'm just going to try to figure out what two numbers are going to multiply to give us negative 3,400. In order for them to add up to be a positive number and multiply to be a negative, one of them is going to have to be a negative number. The positive number just better be bigger in order to end up positive. So 3,400, if I divide by 2, well, 1,700 and 2 are not going to give us 150. So we better pick a bigger number and go from there. 3,400 divided by 10. 340 and 10. If you add them, 350, or subtract them, 330, still not going to be close to 150. So let's pick a bigger number. If I divide by 20. Ooh, wow, I just randomly guessed the right number here. 20 and 170. If you add them, that would get 190, but if you subtract 170 minus 20, 170 and a negative 20, that'll give you 150. That worked out a lot quicker than I thought it would. So in my box here, my two diagonals are a negative 20x and 170x. Those are these two. My first term comes from the first box here, goes in the first box, and then negative 3,400 at the end. So x times x is x squared, x times 170 there, x times negative 20 there, and we already know those multiplied because we just checked it in our calculator. So we have x plus 170 equal to 0, this piece, or this piece, x minus 20 equal to 0. If you wanted to write it all out, 170, x minus 20, you could. I just split them up right away. So if I subtract 170, x equals negative 170. Or if I add 20, x equals 20. Now just be realistic for a minute. Can you have a side length that's negative? You say, I'm going to build a patio that's negative 170 feet. That doesn't make any sense. We can't have a negative answer. So our patio has a width of 20 feet. Alright, your homework is 9.5. If you have any questions, please let me know. Otherwise, we just did this one right here. There's one that's very similar on this next problem as well. Good luck!